Hi, in today's video, I would like to introduce you a very nice problem of Dutch Mathematical Olympiad of 1991. Here is a statement. There is three numbers, A, B, C, as real numbers, satisfy these equations. So we have these three equations. The first equation, we have the sum of these numbers equal to 3. We have the sum of the square for each number equal to 9. We have the sum of these cube numbers equal to 24, okay? So the question finds a to the fourth plus b to the fourth plus c to the fourth. If you take a look at these three equations, here is a nice thing here. All the numbers are cyclic because they are written in the same form. If you take a look at the first equation, each number has the same exponent, which is number 1. In the second equation, they have the square as an exponent, have the same exponent, which is number 2. In the last equation, they have number 3 as an exponent. Even the question, we have the different numbers a, b, c, but they have the same exponent. So which is more helpful to find those numbers, okay? Go ahead, pause this video. If you would like to give it a try to this problem, when you worry, come back to see the full solution, okay? Let's jump into the solution now. I'm going to start with this one, how to find these numbers, okay? In order to find this a to the fourth plus b, in order to find these numbers, we are going to square the second equation, a squared plus b squared plus c squared equal to 9, okay? Because the only way we can get a to the fourth, okay? So here is a second equation. We have 9 equal to a squared plus b squared plus c squared equivalent. I'm going to square both sides. We'll have 9 squared equal to a squared plus b squared plus c squared quinary square, okay? I'm going to factor this one out. This one, if I'm going to factor this one, I'm going to write this one on this form, a squared plus b squared, as I have the quinary square, as I have a quadratic form here. So this one will be written on this form, plus 2 times c squared is multiplied by b squared is multiplied by a squared plus b squared, plus the last term, which is c squared quinary square, okay? If I'm going to simplify this one, I will have area 1 equal to a squared, which is a to the fourth plus b to the fourth plus c to the fourth, plus 2 times a squared b squared plus 2 times a squared c squared plus 2 times b squared c squared, okay? So what I'm going to do now, so I have this is the question, a to the fourth plus b to the fourth plus c to the fourth, but is it required, we need to find these numbers, okay? So in order to find these numbers, I'm going to use the trick. We have a plus b quinary square equal to a square plus 2 times ab plus b square, okay? So this one, what I'm going to do now, I'm going to calculate 2ab. See, this one equivalent 2 times ab equal to a plus b quinary square minus a square plus b square, okay? So what's the next? I'm going to divide both sides by 1/2. So we'll have ab equal to 1/2 a plus b quinary square minus a square plus b square, okay? In the same time, I'm going to raise the number 2. I'm going to raise the number 2 as a power on both sides. I will have ab square equal to 1/4 a plus b quinary square minus a square plus b square. The whole thing is the whole thing is quinary square. Okay, so now I'm going to multiply both sides by 2. If I multiply by 2, this one equivalent 2 times AB quinary square equal to 1 over 2 A plus B quinary square minus A square plus B square. Okay, the whole thing is quinary square. So I'm going to calculate A plus B and A square plus B square. A plus B is coming from the first equation. Okay, so the first equation I have A plus B plus C equal to 3. Equivalent A plus B equal to 3 minus C. For the second term is coming from the second equation. I have A square plus B square plus C square equal to 9 is equivalent A square plus B square equal to 9 minus C square. Okay, I'm going to replace these terms into this equation. So I will have 1 over 2 A plus B quinary square, which is 3 minus C quinary square, minus this term, which is 9 minus C square. The whole thing is quinary square. Okay, if you take a look, I found all these values A, B, C in terms of C. So I'm going to simplify this one more. So now I have 2 times AB quinary square equal to 1 over 2. I'm going to put 3 minus C as a common factor. Before I do that, I'm going to factor out 9 minus C square. Okay, this one, if you take a look, this term is giving me 3 minus C is multiplied by 3 plus C. Okay, so I'm going to take this term 3 minus C and 3 minus C as a common factor. So I will have 3 minus C is multiplied by 3 minus C by itself minus 3 plus C. The whole thing is quinary square. Okay, so this 3 will be cancelled with this one because we have 3 minus 3. We have minus C minus, which is minus 2C. Okay, so this one is minus 2C is multiplied by this one. If I'm taking the quinary square of this one, is giving me 1 over 2 3 minus C quinary square minus 2 quinary square, which is 4 C square. 4 C square. This 4 will be cancelled out with number 2, so we'll have 2 here. Now I'm going to simplify this one. This one is giving me I'm going to put number 2 outside. I will have 2 is multiplied by C square. I'm going to simplify this one. This one is giving me 9 minus 6C plus C square. Okay, I can rewrite it in order. So I'm going to simplify this one more. So I'm going to multiply this one out. I'm going to distribute this one. I will have C to the 4th. I'm going to put this one in order. Minus 6C cubed plus 9C square. Okay, so if you take a look at these terms I did here, I transfer over AB in terms of C. Okay, so this is the first term. As you see here, we have 2AB quinary square equal to 2 times C to the 4th minus 6C cubed plus 9C square. This is just the first term of this equation. If you take a look at here, I just calculate this one. It will be the same thing with B and C. We found the first term, 2AB square. We found this term as a first term, which is 2 is multiplied by AB quinary square equal to this term. It will be the same thing with the second and third term, because these numbers A, B, and C are cyclic. So this one I will have 2 times as a second term A square C square
equal to 2 times what I did here. I'm writing AC in terms of B, as I did before, AB in terms of C, AC in terms of B now. So I will have 2 times B to the 4th minus 6B cubed plus 9B squared. Okay? For the last term, which is 2B squared, BC quinary square, it will be 2 times multiplied by A to the 4th minus 6A cubed plus 9A squared. Okay? I'm going to add all these terms together, plus last term, which is 2 times A to the 4th minus 6A cubed plus 9A squared. So I'm going to put these two together as a common factor. Okay? So now I'm going to collect all these terms together. So I will have area 1. So this one, I will leave this one as is it. So I will have A to the 4th plus B to the 4th plus C to the 4th plus 2 times. If I'm putting all these terms together, now what I'm going to do now, I'm going to put this A to the 4th plus B to the 4th plus C to the 4th. I'm going to put this first term together with this term, is giving me 2 times A to the 4th plus B to the 4th plus C to the 4th. Number 2 with the 1 is giving me 3 times, plus these terms. So now I have area 1 equal to 3 times A to the 4th plus B to the 4th plus C to the 4th plus 2 times 6 times 24 equal, it is given as 144, which is minus 144, plus 9 is times 9 equal to 81. Okay, I'm going to simplify this one more. I will have 207 over 3. Okay, this is the value of this number.